speakers. So please have a seat, and we are ready to start. So I'm Franck Carré. I'm with the French Commission for Atomic and Alternative Energies, and I'm a chief scientist of the Nuclear Energy Division. I'll be very pleased to, let's say, co-chair this session with Mr. Roger Garbil, whom everybody knows because he's one of the main organizers of this very successful conference. As you know, he's a project and policy officer in the Euratom Research Unit of the Directorate General for Research of Innovation at the European Commission in Brussels, Belgium. And also, we will work with Ms. Theodora Rettegan as a rapporteur, and she's an associate professor from the Chalmers University, and her field of expertise is chemistry and chemical engineering, nuclear chemistry, and industrial materials for recycling. Just a few remarks just as an introduction to this session on advanced nuclear systems and fuel cycle. So let's say over the past months, there have been signs of increasing awareness that nuclear should be part of the low carbon energy sources to really achieve carbon neutrality by 2050. And I just take three examples. European Commission had a communication in late November that stated that together with, let's say, renewable energies, 15% of nuclear power would be the backbone of a carbon-free European power system. So this is one statement. Another interesting statement is in the International Energy Agency a special report that was presented last week at the 10th Clean Energy Ministerial in Vancouver, and that stated that nuclear power in a clean energy system, and this is the title of the report, Nuclear Power in a Clean Energy System. And really this was a communication that the nuclear was really among the, let's say, low carbon energy sources to really fit within the 2 degrees or 1.5 degrees. The third and last example is, let's say, a statement by the Union of Concerned Scientists in the United States in a report that was published in November 2018 that says, so the sad reality of serious climatic changes dictates that we keep an open mind about all of the tools in the emission reduction toolbox, even ones, and in parentheses such as nuclear, that are not our personal favorites. So I think those are signs of increasing awareness that really nuclear should really team with renewable energies towards a carbon neutral energy future. But for the nuclear to really be a strong part of the energy mix in 2050, there are a number of conditions to be met. So improving cost effectiveness and flexibility, enabling high levels of safety at lower cost, assuring a sustainable long-term fuel cycle, resolving nuclear waste and environmental issues. And then improving nuclear along these lines calls for innovation and fosters research for new technology, new designs, new reactor types, which is the precise theme of this session. So this makes the current period and the years to come quite interesting because innovation really is required, and there are signs of emerging innovation. So it makes the coming period very interesting and also decisive for the future of nuclear power and possible extensions to other energy products such as heat and hydrogen. So within this context, we have an exciting session on advanced nuclear systems that will well reflect the current spirit of innovation with, let's say, a wide variety of nuclear systems and the presentation of a wide variety of innovation in key topics. And we will start with the keynote presentation by Dr. Noël CAMARCAT. So Dr. CAMARCAT is the Director for Research and Development and International Affairs at the EDF, our utility EDF in France. And prior to joining EDF in 2007, Dr. CAMARCAT had a distinguished career at CEA, where he had several key positions, including that of Director of the Fuel Cycle Divisions at the end of the 90s. So please, Noël, please, the title of your address will be SNETP-ESNII and EERA-JPNM Research and Innovation.
Thank you, Frank. You know me far too well. I am only a reasonable special advisor for nuclear R&D at EDF Engineering and New Nuclear Project. And I speak to you as ESNII Chairman, European Sustainable Industrial Initiative, using Generation 4 demonstration fast reactors and their relationships with the material science community the EERA-JPNM, Joint Program on Nuclear Materials. The projects of JPNM will be detailed in the session by Lorenzo Malebra from CIEMAT, who is in the front rows, and they will be detailed later in the session. So who are we? We are a task force, and we work under Memorandum of Understanding under the SNETP platform. We were founded in 2010. We were 13 founders at the very beginning. We are now 31 members. And latest comer is Paul Scherrer Institute from Switzerland, who joined in 2017. From industry, we gather 12 members. From research organization, mostly funded on government money, we gather 19 organizations. And as is classical in the SNETP platform, we have a two-level structure. Basically, ESNI is an instrument for coordinating the implementation of the platform pillar on sustainability of nuclear fission based on generation 4 fast reactors with a closed fuel cycle. 3 main technologies are studied in Europe with the objective to reach the demonstration stage. It is an ambitious goal, beyond €1 billion minimum. It's a minimum. We have the following technologies: lead bismuth and pure lead, sodium fast reactors, and gas fast reactors. Now, in the past 10 years, the maturity of our projects and systems have evolved. Between 2010 and 2018, sodium fast reactors were the leading technology and demonstration project in Europe. Remember, I'm speaking only for Europe. The world situation is quite different. In early 2019, there was an announcement by the French government that sodium demonstration projects are no longer needed for the short and medium term, as industrial perspectives for sodium reactors are postponed. And the new French strategy for closing the fuel cycle has been detailed by a high-level government officer, who is Philippe Storr, from CA Director for Nuclear Issues, and he gave this formal presentation at a recent conference in May 2019. So since I'm no longer a government officer, I will duplicate some of his official presentation. So now the MIRA demonstrator, SCKCEN, is now the leading Generation 4 project in Europe. It uses lead bismuth as a coolant, and it will be Hamid, also in the front row, who will be saying most of the things concerning MIRA. And now the 2 other technologies, pure lead, sodium and gas technologies are also studied in Europe. We had a lively debate at the seminar this morning. What can be said is that the demonstrator stage is not yet as advanced as the stage of MIRA. Okay, so this is MIRA. Remember, it is a multi-purpose flexible irradiation facility. It's an accelerator-driven system using a 600 MeV proton LINAC and a spallation target source and a cooled reactor with the lead bismuth, which can operate in the 2 modes. It is a multi-purpose flexible irradiation facility, serve the category of research reactors. We now go to lead technology, pure lead, and we had a very good presentation of its objectives by Senator Valeka, Romanian Senator Valeka, this morning. So it, in a way, has a variety of objectives. It is both a demonstrator devoted to the development of lead fast reactor technology. It can also be a reactor addressing the concerns of safety and sustainability of nuclear energy. And it is also a research infrastructure to build and maintain the European leadership on scientific excellence. I have quoted here power range. The power range of Alfred would be of the order of 120 megawatt electrical, which qualified such a project in the category of small modular reactor. In order to get the modular objective, you have to take a look in a more detailed way at the design. Remember that power is not enough. Next, the Falcon project. supplemented, we heard this morning, by a national Romanian project, the Jesina National Project. So originally the Falcon project was founded in around 2013 or 2014, just before 2014. It joined Ansaldo Nucleare, ENEA from Italy, and our host in Romania, which is ICN Ratten. It is useful both at the EU level, at the national level, and of course at the local level. And the Mioveni nuclear platform in this very country is the candidate site for Alfred. If you are optimistic, if money can be raised, but we have heard some good news this morning, then construction can be envisioned in the 2030 range. And the collaborative effort around Alfred is very original, typical of Romania. It is a research infrastructure covering many scientific objectives. And again, at the specialized seminar this morning, at the session, we heard a very good presentation from Dr. Tarantino from ENEA on pumps, big components, steam generators, fuels, and also innovative concepts. For instance, in fuel, you have understood I am a fuel engineer by training, they want to use grids, not hex counts. The EU has given a great amount of support to the Alfred project. So this slide was already presented this morning. So you can see R&D indirect and R&D direct actions. You can see of the order of 90 million euros. Of course, this is over a 10 to 15 years period, many projects. And in the memberships, associated members and partners can provide what is called in-kind contribution. Now we now come to the, also Romanian support should be always mentioned. You can see on this slide, past initiatives are all of the order of 50 million euros. Short-term availability is anywhere between 2 and 20 million euros. And there are good plans in the future and for the facilities mostly, which I've seen this morning, with the use of European structural funds up to 45 million euros to support the research facilities for the components. I now go to the second European fast reactor technology, which is the gas fast reactor technology. It originates from a design going back to 2000-2005 on the left-hand side, the Allegro design of 75 megawatt thermal. And there was in the 2000, so that's nearly 20 years ago, a plan to make a jump between such a design and a FISA 2400 megawatt thermal reactor. The technology in itself has a few tricky parts. You must have a reactor vessel. You must have, of course, main heat exchangers. You must have decay heat removal systems, because in gas systems, if you have a leak, then you lose the pressure and the coolant at extremely rapid rate. And you have to have what is called a guard containment vessel, enclosing the reactor vessel itself and the loops in order to provide backup pressure in case of lockout. And it has taken the Central Europe team quite a number of years in the SNETP structure, but also nationally, to gather expertise, knowledge, and to be able to reach that point of the order of a good conceptual design. Now they announced a new strategy that's early 2015, so that's already 4 years ago. The partners V4G4 are from Central Europe, Czech Republic, Slovakia, Hungary, Poland, with the French CA being an associate member. So the idea was to start building, if possible, rapidly. Rapidly can mean over 10 years from time to time. So reduce the power from 75 megawatt thermal, optimize the core configuration, gather a team between 4 countries to be able to do a conceptual design, which is not very easy. It takes some time. It is easy, but you have to discuss, negotiate, take time. And 2 major technical decisions. concerning the management of loss of coolant accidents and station blackouts, and the other one concerning fuel, so uranium pellets, enriched uranium pellets, MOX maybe, but mostly enriched uranium in stainless steel. So you build the first machine and then you qualify the true material, the true fuel, which is a ceramic fuel. So here is an example of the calculation performed by the Slovakian team, Vuje. You can see on the left-hand side a core going up to 75 megawatt thermal. On the right-hand side, a reduced core going up to 37.5 megawatt thermal. And I have recalled at the bottom, with the help of the Allegro people, the outlet temperatures. If you have a classical core, you can go to 560 degrees C. If you go to ceramic with a carbide and silicon carbide, then you can go to much higher temperature and reach 850 degrees C. Now we go to some news from France. We had Mike, as you have understood, I am a French gentleman. So there was indeed a major evolution in 2018, announced in early 2019. So yes, France wants to keep the closure of the fuel cycle, but generation 4 reactors will be pushed back in the long-term future. So in the short term, we have an industry and we have plans to run, so we will introduce MOX fuel to the 1300 megawatt PWR reactor fleet. This is a big fleet. We have up to 1300 megawatt machines. Not all of them will be on MOX fuel, but this is already a big industrial effort. In the medium term, the government is requesting that we investigate the multi-recycling in PWRs using what is called now MOX2 fuels. So we have, you have to, well, I will not go into the details, so you should call them second generation MOX fuels, so new fuel assemblies. You can use enriched uranium rods, so Corail and mix assemblies, and you try to find the limit multi-recycling in thermal reactors. And long-term still remains generation 4 reactors and full closure with sodium reactors and corresponding cycle plants. So again, you can see that we have an R&D program going on between French CEA and industrial partners, EDF, Framatome and Orano company. The main effort which is now starting and going up to speed is study the potential industrial deployment of multi-recycling in pressurized water reactor. You do that both through scenario studies and you do that also with what would an experiment look like. And so the idea is to go from mono-recycling or single recycling to complete fast reactor recycling of plutonium, but fast reactors are pushed back to the end of the 21st century. And you have a number of scientific challenges to be addressed, which I will not detail. I'm a bit short on time. We are also thinking about small modular reactors. Maybe most important, we are now reaching 10 years beyond the creation of the ESNI organization. So it is time to reflect about what we have been able to do. So one, we do promote main projects and technologies. We always think in Europe of projects and technologies, which is not the same as a technology by itself or a project by itself. Maybe I'll get questioned. But we do not distribute money. So what do? We evaluate project and systems maturity. As you've seen, it can change. In the course of 10 years, a technology and a project can be moving very fast, and the one can be slow. You take a look, 7 years later, it has changed, as happened between ASRID and MIRA, to be very frank. We do coordinate research and European research teams, because there are very good European research teams, and they should be helped, encouraged, get advice in their efforts. We try to give technical advice to emerging projects, whatever they are, The emerging projects of the future will not be the emerging projects of 2010, 2011, 2012. In the technical field, and we had a debate this morning already, we have achieved some harmonization of fast reactor fuel for R&D. I'm speaking only for R&D in Europe, and mostly fast spectrum. When you take a look at other generation 4 fora in the world, the communities are much more diverse. In Asia, you can find 3 fuels. You can find carbide in India, you can find metallic in India and Korea, and you can find oxide, for instance, in Japan. In Russia, which is an enormous, big industrial player in fast sodium reactors, you also have 3 types of fuel. You have pelletized MOX, you have what they call vibropacked MOX, and they have strong research on nitrates. Of course, Generation 4 International Forum, GIF, worldwide, is powerful enough to treat all kinds of fuels. We are a small pillar in a platform in Europe, so we try to specialize. Now, for the next 20-25 years, EERA-JPNM will use one R&D fuel for the leading projects, for the demonstrator projects. Of course, there can be other basic research. I will maybe tackle that with the moderator. So the idea is to promote mixed uranium and plutonium oxide, pelletized MOX. We have no other thing in Western Europe. And there will be a small offshoot for the Allegro program. Phase 1, phase 2, they will probably be using uranium, enriched uranium oxide. We believe that such a choice must be consolidated in a detailed research program in the future for the next 10 years. For the 2019-2023 Euratom R&D program, MOX fuel research is funded through the INSPIRE and ESFR SMARTS project with European Commission money and also with Member States money. We are very grateful to the Commission to provide such a support, even though it is modest or medium amounts of money. They maintain very good research team, and on this research team you can foster new ideas for larger scale projects, and this is what we do with the industrial French partners. We are also funding fast spectrum MOX at a higher level, a few times higher than what the Commission money is able to do. We need to increase knowledge on second generation plutonium which is coming from MOX, from PWR fuel, and we want to maintain industrial capability in France, which will be useful for all the other projects. If MIRA has to start the fuel off on its own, it's another €1 billion that you have to find. If you can reuse already existing industrial facilities, then it is much easier. I make the same offer to Alfred. Please do stay to MOX fuel, but you can go to other fuel in basic research. But if you have to build a huge, big facility for several tons in nitrites, my God, you have another big tag of beyond €1 billion. Coming back to the technology projects, MIRA has moved ahead significantly, is now the first European fast spectrum demonstrator project in the SNE community. And let me recall that if the French government has made decision for its own country, sodium is technology worldwide, is becoming industrial. I am very glad to recall the production by BN 800 Russia, 5.6 terawatt hour. So this is indeed no longer research. This is an industrial reactor heating and providing electricity to a whole region, to a whole oblast, Yekaterinburg. So large power reactors will remain the mainstream of this technology, but other ideas can emerge in Europe, and there will be small modular reactors using the sodium technology. Teams are gathering, and so we will reuse the work of the previous European projects. Allegro and Alfred are particular since they have access to European Structural Fund. I was very glad of the seminar this morning. 22 million euros of Romanian Structural Fund are in the pipe. They will be very well used for research facilities in Mioveni. So congratulations. I hope you do get this Structural Funds budget, and then you can move on with the project. I was glad to see an upper end figure, up to 100 million euros. Congratulations again. Please do succeed. And the 4 projects, whatever the technologies, will need public support and acceptance from the R&D community at large. They will need long-term research in parallel with project basic and detailed design. As everybody in the room knows, construction will depend on the funding, so good luck to everybody who is looking for fund. Thank you.
Thank you, Noël, for having chaired for so many years SNEI, and also for this quite informative overview of the program. Are there questions to Mr. CAMARCAT? Please.
Yes, Janne Wallenius from KDH. Yes, it's quite clear that the focus in Europe is on MOX fuel. There is also a country that we don't know if it is in Europe or not, the United Kingdom. And the government in the UK granted feasibility study money for 8 different companies to develop advanced modular reactors. And here it's quite interesting to note that not one single of those concepts actually would apply box fuels. They would operate on trisofuels or uranium oxide or uranium nitride fuels, and well, enriched as such. But what is your comment on that?
How many are fast spectrum? If they are light water reactor...
Four fast spectrum reactors.
Okay, so in that case, they have to develop their fuel, so it's another few billion euros on the table.
Well, the UK government has made the assessment that that is more feasible than MOX fuel nowadays. So.
Okay, we'll see, we'll see. Again, I repeat, any project saying I'm going to run on MOX fuel has capability and has a lower price tag, and they are always already all looking for money. This is only one part. Then you have technical difficulties. If you go to very high temperature sintering with not so good quality plutonium, then you are running into difficulties. But we'll see.
Other question to Mr. CAMARCAT. Take a chance because Mr. CAMARCAT has a harsh time constraint, so he will have to leave soon, so please ask questions. I have a difficult question for you.
We have known each other for 27 years.
Well, you said that in fact SNEI was born or launched 10 years ago, and then and you've been chairing SNEI for a long time. So what are your vision of priority research and outcome for, let's say, SNEI in the maybe 10 coming years is too short, maybe in the 20 coming years? So both in terms priority in terms of research and possible outcome in terms of technology demonstrator.
I believe we should continue with our original charter. So somebody has to promote demonstrators in Europe. It is a difficult task. It would be much easier to go to smaller projects and say, okay, let's take the fashion and say, okay, there is a new fashion, let's pick it up. We stay true to our charters, so I believe for the next 15 years, EERA will be the leading project in Europe, and I wish extremely good luck to Alfred and Pure Lead Technology. They have a right to succeed. There will be other smaller technologies. Janus has mentioned it, and we will see how they fare. Well, that's basic belief. So continue to promote demonstrators. Do not let it, the very limited amounts of money we can gather starts going into a few small rivers.
Thank you, Noël. Any last question for Mr. CAMARCAT? Conchetta. Conchetta Facio.
Another difficult question. Yeah, thank you for your nice presentation. My question is as well difficult. So we are observing a certain trend worldwide on molten salt reactors, with also some announcement to build prototypes. So what is the perspective inside the SNEI looking also on this type of reactors? I mean, enlarging a little bit with respect to the 4 systems there.
Again, our individual members, some of them go and join this molten salt reactors project. Well, you say, very good. If one molten salt reactor emerges with enough support from member state governments, then he's eligible to our charter and he can join us. And I had discussions with the Netherlands government in a set plan conference, that was during the terrible days in Brussels for all who remember 2015, 2016, when they had this attack. And I told the Netherlands government, please, you are a member state, if you want to fund a big team, why not? But what we cannot do is have a few university professors with 3 PhD students and say, we want to join ESNI on molten salt reactors. I think it is not our spirit. Try to reach either the demonstrator stage or the conceptual design for a demonstrator. But in molten salt reactor, this is far away.
Thank you, Noël. Let us thank Mr. CAMARCAT again.